2:30, we'll go ahead and get started. There might be some people trickling in since sessions might be running up to 2:30. So I'm Matt Bushy. This is Secure by Design. I'm a consultant based in Des Moines, Iowa. The best time to ask a question is when you have it. So raise your hand. If I don't see you, just yell something out. That's fine. So why Secure by Design? One of the biggest problems we have in software is we don't think enough about security. We hand it off to another team at the end of the product lifecycle, and it causes a lot of problems, a lot of headaches that we could remove if we thought about it earlier in the lifecycle. So there's a lot of words here. Most slides will not have this many words. So there's an OWASP top 10. They kind of stopped doing the top 10. It's really a top 30 now. So that's why this says 2017 and not 2019. But if you look, the differences between 2013, which is now 6 years ago, and 2017 is we lost 7, 8, and 10 and added XML, broken access control, and insufficient logging. So basically, 7 and 8 kind of go into a broken access control, and 10 doesn't really fit into any of these. But in 6 years, we've gotten none better in preventing vulnerabilities, which is obviously a problem. So we all want to know, like, what can we do so our company doesn't end up like Equifax did? So Sneak, they're a tool. How many people have heard of Sneak? A couple? Okay, great. So they released an open source security report earlier this year. And over the past 2 years, there's been an 88% increase in application vulnerabilities. A lot of this is driven by open source software, which is not code you write yourself, but you package it into your application. Still obviously a problem. Third one there, ReDos vulnerabilities and NPM spiked by 143%, and XSS continues to grow. We'll dive into both of those later on in the talk. And the top 10 most popular Docker images each contain at least 30 vulnerabilities, and I'll kind of get into that a little bit more too. So can we fix this? Obviously, that's why we're here. We're all trying to get better. So current state of application development. Oh, it's good. We'll just put this arm right here. No one will drive around it. No one would ever do that. Well, everyone drove around it, so this isn't secure at all. So this is kind of like a JavaScript validation for your website. Will prevent or stop the people who are trying to be legitimate users and not malicious, but it's very easy to work around that. So like if you have JavaScript validation only, no server-side validation, people are going to drive around your JavaScript validation and cause you some problems. So one of my favorite stories, this is from 1854. So there's a book literally called Secure by Design. They tell this story. So 2 guys broke into a bank. The front door was locked. So all right, the JavaScript validation was there. The front door was locked, but there was a key above the door. So this was in the 1850s. No one thought people would break into their house. So there's a key hanging above the door. Obviously, they got into the bank. So the vault lock was top notch. There were laws around like how secure the vault lock had to be. There were not laws around how secure the hinges had to be. So they broke the door open, the hinge side, stole all the money, and that's why, no one would ever do that until it's the easiest way to do something. So they couldn't break through the lock side. They broke the hinges, took the door off, stole all the money. So the key here is they found the weak spot. It's obvious what the weak spot is here. It's not obvious where the weak spot is in all of our applications. So current state of application development, we spend months working on something, pass it over to the security team, they run some scans, we're all ready to go to production, and we find vulnerabilities. Awesome. It's a setback, obviously, to the team. We missed our deadline. Everyone's like, why do we do this again? So how do we fix this? We'll take a hypothetical new application. So this will be a Java application. We'll have an Angular front end. We'll build it into a Docker image, we'll build it using Gradle. We'll use a Docker image. We'll deploy it to AWS. So we've got 5 places just here where there can be vulnerabilities, plus any vulnerabilities that you may create yourself inadvertently in your application. So like I said before, the top 10 most popular Docker images each contain at least 30 vulnerabilities. So the problem here So this node version here has 580 vulnerabilities. Sorry, next slide. Why is that? It's because this uses an old version of Debian that's no longer supported. But people go to Docker Hub and they see, okay, everyone's using this Node 10 image, it must be good. Well, it's not. It's just, it was good at one point, and now it's not, but everyone's been using it, so it still stays at the top of the list. Theoretically, the Alpine version will always have the bug fixes. As soon as they find them, they release updates. 0 is not really an accurate portrayal, but that is hypothetically what they're going for. So 78% of vulnerabilities are in indirect dependencies. So this here is the dependency tree for uglify.js. So it includes source map and async and all these things, which include things, which include things, and include things. So there could be a vulnerability. Now, probably when you're getting down here, this is like something like left pad. There's 3 lines of code. But still, there could be a vulnerability all the way down here. And maybe to fix that, they have to make a breaking change. So then this is broken, and everybody has to update before uglify.js can get rid of the vulnerability in that final package. So that's something we've got to deal with every day. So it's a new mindset that you have to take into your software development. How many people have read this book or heard of this book? 1? Okay. This is a great book just talking about the mindset you have just in life, not just related to programming. So you can have a fixed mindset where you think like you can't get better, everything's terrible, or you can have a growth mindset where you think you can improve everything, and that's the mindset you need to have to not write or to write better code. So it needs to be a concern in the application, not something you add on at the end of the application. It is baked into the application, and most importantly, good design will deliver security. So the new future state of application development, we'll assume we're using Git here and not SVN or something else. But you will commit your code from your computer, and say you're going to use GitHub. The code goes up, and you create a pull request. So I've got a new branch up here, add form validation. So what happens is we have hooks that run. So this is obviously in GitHub. This would be a Jenkins file. In this example, you could use something like Concourse, or really any other build tool can run these individual parts to tell you about issues in your application. So the first thing we have run is SonarQube. So this will point out vulnerabilities and also just kind of best practices. So like here it's saying you should use character.toString instead of whatever we were using. So this may be more secure than what we were using. It's also just, it lets you know, like this is just a better practice than what I was doing. So the nice thing about this, the Sonar task, you can run this against your own computer so that no one else has to know I had these 4 vulnerabilities. Everyone thinks you're great because your SonarQube test pass. There's never any issues. But you can also run something in IntelliJ. So I'm referring to a Java app in this instance. But IntelliJ will say, hey, you use this old method that was designed for Java 8, but you're on Java 11. Do something like this. So that's just under, I think it's inspect code. I'm not sure. But it will tell you exactly improvements you can make in your code, which will also help eliminate potential issues. So in this application, we're also running our unit tests. Okay, 63 tests passed. We're running our Angular end-to-end tests. All 55 of those passed. We're running a security scan. In this instance, this is a fake one, but it says we found an XML parsing vulnerability. Hopefully you don't have to use XML, but XML has a ton of vulnerabilities in it because of the way it does namespacing. So if you have to write a lot of XML or maintain XML, that's a huge source of security pain. And eventually you'll get to something like this. We've got all these green checks. Hopefully you cannot merge until everything has passed. You rebase and merge and your changes are in there. Great. So sounds complicated. And it is. That's why all this stuff should be automated. You shouldn't have to do anything individually on your computer. You could have the option to run it on your computer, but it's going to run as part of the pull request check overall, so no one can forget to do it. If you have to do it yourself, you're going to forget, or you're just not going to care, and you'll add bad code into trunk. So how do you get your team on board? Well, one, everything's automated, so there's no excuse, oh, it didn't work on my machine or anything like that. Everything is ran through some sort of version control or Jenkins file or concourse. Everything is automated, so all the notifications are automated. And most importantly, this won't be a thing anymore. Deploying to production is no longer an event. Like, how many people you deploy on a Friday night at 10 o'clock, and then you're scared you're going to be up till 5 in the morning because you found an issue? Or how many people deploy not during the day at their day job? Yeah. So ideally, you can deploy during the day. You work 8 to 5 or whatever your core hours are, and no one cares where you are outside of those hours. And if there's issues, you can easily roll back, which is also a huge perk. So how do we fix that top 10 list of OWASP concerns? So the first one, not really going through in order. This is the order that I thought made sense. So insufficient logging and monitoring. So the average is it takes 200 to 279 days to detect a breach. And usually that's because somebody came and said, hey, Matt, I saw your database on some dark website. It's not because you figured it out yourself. Somebody else told you that you were hacked or something leaked to the press, and that's how you found out. So log as many things as you possibly can and try to set up some metrics to tell you when things are going bad. We'll get into those individual steps. So here's an example. Our site was having some problems at the time, but this is for a roughly 14-hour period. We had 30,000 errors. Now, no one's ever going to say, I wish we had fewer logs. You can filter down to the logs you care about. This is a screenshot from Splunk. You shouldn't be looking at individual log files. That would be awful unless you luckily only have one server for your application, which would be awesome. Make sure you're removing any sensitive information. So like we accept credit cards that obviously can't go in your logs, account numbers for a bank, passwords, none of that stuff can be logged. So make sure none of that stuff's getting to your logs because that's also an obvious vulnerability. I don't remember which company it was, Slack maybe? Somebody said they had passwords in their logs and their employees could view them, so it wasn't a security breach, it was still a problem and something that they had everybody who was affected reset their password. So if somebody logs in or is not able to log into your application, what happens? Can I try to log in here 500 times and it just lets me keep trying and trying? Or after 5 times, does it say, hey, you're locked out for 10 minutes or something? See how many people are trying to log in and get an invalid login based on their user ID or IP address. That would be a big red flag if there's more than 5 or 10. And usually it wouldn't even be 10. It would probably be thousands of attempts in a short period of time. So set up an alert in Splunk or whatever your log aggregation tool is to tell you when bad things are happening. So in this case, if there are more than 500 login failures, now there can be legitimate login failures. You can type your password wrong, that's fine. But if we had over a certain number, I think it was 500 in an hour, then we wanted to know about that and we would just go check it out and see what was happening. In this case, it was just high traffic, so not a big deal. Use a tool like New Relic, something that will tell you how your CPU is doing, database activity. So if CPU is spiking, what's happening? Did something you have hung threads? Is somebody attacking the system? What's going on? So broken authentication is another issue. So in this case, I went to the Social Security website. It has multi-factor authentication. So I log in, it sends a code to my email address. I have to use that to get in. So 2-factor authentication is great. It's not the best option, but it is definitely better than 1-factor authentication, especially where if a user has access to your email. Now in this case, it wouldn't matter because they're sending the code to my email. But if I have access to somebody's email, I can usually reset your password and then log in, and I would know your password. If a user has been idle for 10 minutes, what happens? Do you want to keep their session open forever? Like if it's Facebook, then your session is open forever. I don't think it would ever log you out. Or Gmail, it may never log you out. But your bank or credit card probably logs you out after 5 or 10 minutes. What is the appropriate setting for the application you have? It may be forever, and if it is, that's fine. But if you have sensitive information, it should log you out after a certain period of time. Use cross-site request forgery. So the way this works is when you submit a form, it submits a token with the form. And after a certain amount of time, that token is invalid. Or if there isn't a token, it's obviously invalid. So you try to submit the form. That token is not the valid token that should have been with the form. It doesn't accept the input. Sensitive data exposure. So here, this is my Social Security account. They don't need to display my Social Security number. They probably don't even need to say the last 4 because it's mine. But if for some reason your users need to know something about a Social Security number, what do they need to see? Do you need to have all 10 digits on the screen at all times? Most likely not. Do you even need the last 4 digits? Maybe, maybe not. It depends. Are they calling in and that's a verification step as they say their last 4? You can maybe have a button here that says show the last 4 of the Social Security number and log when people click that to see if maybe you have somebody malicious inside the company. Ideally, you would not be storing anybody's Social Security number other than the last 4 because that's, I mean, all of our Social Security numbers are probably out there because of Equifax, but you don't want to be like them. Use SSL. If you're not using SSL, this causes problems with search results, and your site obviously is not secure. There's a lot of problems. Google even warns you when your sites are not HTTPS or SSL. It's very easy to add an SSL cert to your website. You can use something like Let's Encrypt. It's free, 100% free. It costs you $0 to do. So if you don't have an SSL cert, make sure you're getting that taken care of. Passwords. No one should be storing plain text passwords, but you also shouldn't be storing just the password that is hashed. So one thing you can do, they call this salting the password. So I've got a table after this. But for this example, we're going to take, so we've got a user ID. I'll just skip here. User ID 1001. And the password is just password1. So what we're going to do is take the left 2 of my user ID. So that's going to be 10. And then we're going to append the user ID also at the end. So what this does is if your database were stolen, your passwords are all hashed and they would be unique. So in this case, we had these 5 users with the same password. The database is stolen. They see there's 5 people with this. Password1 is the most common password. So they can infer or figure out everybody who had this hash probably has this password1 or testing1 or QWERTY1 or whatever the top 10 most popular passwords are, and they could get into accounts easier. So if we do something like this, when we hash it, it's these different values. So the user is still only typing in their password, but when you hash it, you're appending some values or prepending a value and appending a value so that everything in the database is different. No 2 hashes are the same. If your database gets stolen, it's bad, but people aren't going to be able to get into accounts. Error messages. So if I type in an invalid user ID, don't tell me that user ID doesn't exist. Or if I type this user ID, which I think is probably invalid, don't tell me my password's wrong because this user exists. Give as few details to the user as possible if they do something wrong. Now, you're not going to be able to distinguish between somebody who fat-fingered their username and somebody who is being malicious. So provide no extra context. Give them an option to reset their password or retrieve their user ID and send it to their email address. Hide the platform that you're running on. So if you're on WordPress, yeah. We don't do that, but I can see how that would be an idea people might like. But I do agree it would be really hard as a developer to decide, was my post okay? Did I send an invalid data? Or I haven't heard of that one before. So hide the version you're using. So WordPress used to have something in the HTML that would say like WordPress version 5.1.0. So if we're on 5.1.1, there's vulnerabilities in 1.0 that were fixed. So hide as many versions from people as you can. There's going to be vulnerabilities found in WordPress, Drupal, Angular, React, Vue, everything, every Java library. It's just inevitable. No one writes perfect software, especially when you're relying on numerous open source projects. There's no chance that everyone's ever going to write perfect software. Make sure you're hiding your stack trace. So in this case, somebody tried to divide by 0. Not good, but you shouldn't be exposing the stack trace because that can show them many different things, where the files are located. Maybe it shows like a SQL query in here. Nothing good will come from showing a stack trace to a user. Even if you hide the stack trace and return the message, and say attempted to divide by 0, I wouldn't return the actual error message that you get from your system. You could return, well, you should be able to catch this on the front end and say you're dividing by 0 and say you divided by 0. You could even copy this message, but don't return the exact message from the server because that could be something that is way more specific than this one's pretty, it's not malicious, but it would be easy to get a bad error message. So what happens if somebody knows a URL? So in this case, we're saying a user has to be an administrator to access this page. So if we didn't have code like this, I could go to my website /admin and potentially access all the admin files, which is not good. What happens if you change URL parameters? So in this case, I swapped out some order IDs on Best Buy. One was a legitimate order, and one was an order that probably exists, but was not mine. So they say, we're sorry, order information is currently unavailable. So they give a super generic message. They don't say, hey, this order was for John Smith, or you don't have access to this order. They just say, oh, it's not available. Now this is maybe could cause some issues because it's really vague and saying maybe it does exist and it just didn't work. But if you're clicking from the order page, you're not going to get an error like this. The same thing happened with whatever the tax agency, I can't think of the name now, but the US tax system, you could switch the URL to different things and view other people's tax returns. This was in like 2014 or 15. So we all have to pay taxes. There was potential that our whole W-2 or tax form, 1099, whatever, was exposed in that breach. So SQL Injection is the worst one. This comic was released in 2008. So I'll give you guys a minute to read it here. Then I'll explain it. And so little Bobby tables. I think people make the joke a lot, but what does this actually mean? If you if you don't use SQL often, you're like, sounds like something bad happened, but what really happened? So what happens is, let's just say they were going to update the first name only in the database. So we run a query. We say update students, set first name equal to whatever was passed in, where the student ID equals Bobby tables as student ID. So what actually happens, because his name was Robert apostrophe semicolon, we run that top line, update student set first name equals Robert apostrophe semicolon. So we've set every student's first name to Robert. Okay, not good. And then drop table students, and then we have a semicolon. So every semicolon and the 2 dashes, which are a SQL comment. So everything after that is escaped. So we updated all the users or the students to have the first name Robert. Then we dropped the table. So Obviously, very poor implementation. It's very easy to write code like this. That is awful. But there's ways to work around this. So one way, you can use query parameters. So the first name has to be a string, so it will escape that. And it would set his name to Robert, drop table, etc. So that prevents some things, better than obviously the alternative of dropping the database. But you should use something like an entity where it knows first name has to be a string, last name has to be a string, the user ID is a string, things are longs, they're ints, they are whatever. It can only accept those types. So in addition to doing this, the best option is using the principle of least privilege. So in this case, what does the user that runs my database actually have to do? Now they probably have to insert users, update users, select users. They probably don't need to delete. If a user is being deleted, you could set a timestamp or an active flag to have them be deleted and not show up in queries. You don't want drop table, you don't want alter, grant, whatever all the other SQL privileges are. You probably want insert, update, and select. So start with the lowest that you think is needed, and if you need more, you can add them. It's not like you're going to go to production day one with this without testing it first. Oh, so don't pass data as hidden inputs. So in this case, I'm updating my address, but my name changed. So like if you get married, your name probably changes. And you may say, you have to call our office to change your name. Well, I'm passing in first name and last name. So in this case, I could change this to my brother's name if I wanted to because it's passed as a hidden input. Don't pass in anything more than you need to, and make sure you're doing all the validations on the back end that name is not being changed, or whatever you said cannot be changed is not being changed. So dependencies with known vulnerabilities. This is the one that's getting to be worse as we use more open source software, which is great for us that we're not writing duplicate code that everyone else in the world needs, but that's where we're getting a lot of vulnerabilities. So OWASP has a dependency checker. There's many other tools. Black Duck, Sneak, Greenkeeper, VersionEye, Contrast Security is another one. So an example of how this works is I created a repo. It's a Spring Boot repo. Sneak hooks into my GitHub repo. And now they know there's an XML external entity injection vulnerability in my repository. So here it doesn't say what. There may not be a remediation yet. If there is something, it'll say, so right now I'm on taglibs standard 112. It might say upgrade to taglibs 1.2.0 or 1.1.3 or something. The good and bad thing with Spring Boot is everything's set up into a BOM. So there's a bill of materials for Spring Boot 2.1 that includes all of these files. So until all of these other files packages are updated, they can't update the Spring Boot version. You do have ways to override this if you're using Gradle or Maven to upgrade to a later version. But there's so many benefits to using the bill of materials versus individually including things, but it does make security updates a little bit harder. So if Sneak can fix this, this is actually now a premium feature, so you can't do this on the free plan now. But if they know that they can fix this by upgrading to 1.1.2, they can open a fixed pull request for you on your repository. And I think that used to be an automatic thing that they would do if you wanted it, and then you could just merge it or not. Yeah, so here was one where it opened, oh, this is a separate thing. This was I had a presentation I did in Reveal that was like 8 years old. So obviously there were a ton of vulnerabilities. Yeah, it's saying breaking change from 2014. But it will try to update it for you, and then you can run your pull request checks, and you'll find out if it actually works. So if you're using Angular, you can keep your dependencies up to date manually. You can run like update Angular core. So there's different ways to update that. So if you know there's some issue with RxJS 6.3.4, or maybe 6.4, whatever, you can type it out just like this. It will never upgrade that version. If you use the caret, it'll stop before version 3. And if you use the tilde, it'll stop before version 7.3. So there's different ways to say how high you want it to upgrade. TypeScript is one that causes a lot of changes. It's gotten much better since it's in version 3. But I would try to leave everything with the caret, the middle one there. And then if you have problems, then maybe back down the restrictions. But otherwise, try to take in the latest code. There's no concerns having the latest code. You're probably going to have less vulnerabilities. So I also ran an NPM audit. I don't remember what this project was. Oh, stocks project. So this was from some book I was working on or working through. So you can run NPM audit, and it'll tell you what vulnerabilities you have in your software. So all this code was doing, it called some backend API that was not part of the repository, and it would display stocks and their symbols. So, okay, yeah. So found 4 vulnerabilities, too low, too high, and there's 40,000 packages in this app that doesn't do a whole lot. So you can run npm audit fix to fix 3 of them. 1 requires a major version upgrade. So just for fun, I ran the npm audit fix, and it removed 35 packages and updated 5. And it says there's still 1 more vulnerability. So just for fun, I ran the npm audit fix force that it has in this last line here. And I did think it was kind of funny, this second line here, warn using force, I sure hope you know what you were doing. I was just messing around. But it upgrades Karma to 4.0, and then it adds 67 more packages, updated 1 and moved 3 packages. So now there's 41,000 different packages just in this little application. So you can see if one of these packages has a vulnerability, it's highly likely hundreds of them probably do. That's how we get into a lot of problems. Okay, so we talked about this at the very beginning. ReDos vulnerabilities in NPM spiked. So this was 3 years ago. Stack Overflow had an outage for like 12 or 13 hours. Anybody remember that? No one else remembers they couldn't do anything for a whole day? Okay. So what happened was they had a regex set up, and people were adding a bunch of spaces at the end of, it was either a comment or a post, and their regex was looking for over like 5 spaces or something along those lines. And when there were more than 5 spaces, the time it took to run the task grew exponentially. So you can see this first string, we're just running a small test against this. It takes 0.05 seconds. Okay, we add like 2, maybe that's only 1 extra C, 1.88 seconds, 3 extra Cs, 7.17 seconds. So you keep adding more Cs, it turns into a big problem. So this kind of goes through the details. So the more Cs you have, obviously, the more iterations it has to run through. And this is called a ReDos attack. So what happened was people figured out this vulnerability. They added all these spaces, and the servers were out of memory because if you added hundreds of Cs here, you're probably running trillions of operations, and very few servers can handle that load. So cross-site scripting. So this is a silly example, but I added this text into a phone number field. It pops up this alert and says hackers. Okay, so first we need to remember front-end validation is not really security. JavaScript is great validation to tell the user an instant feedback. It works for people who are trying to be legitimate users. It is not any sort of validation for a bad user. So let's say somebody's trying to add a phone number or a comment with something malicious. So here I'm adding a comment, says this is a great site, and I add this script tag. Well, when HTML renders, it doesn't render a script tag. So one of you comes to my website where somebody added this comment, and it says great site, but this my website password stealer was loaded in the background. You have no idea. You didn't do anything wrong. You just visited this site probably because they were fixing some issue you had found, and now this password stealer is on your computer. So this isn't so bad if it's maybe your personal computer, but what if you're at work? And remember, this only requires a page visit. This doesn't require you to do anything wrong. You just visited this page that had this bad code on it. I was supposed to talk about, sorry, that's coming up. Okay, so this is called second order XSS. So what happens is somebody will attack a secondary system, and they'll find a way to get a user to be vulnerable to their problem. So just like that password stealer. So, or maybe bad data is logged by a web service. So I view some logs, and they're not escaped properly or not rendered as just text, and that's on my computer, and I'm an admin at a company. So now this user is inside the trust boundary of the company, of the network. They can run everything that I can, which could be super high, top secret access, and then you're hacked. Somebody's in your system, they've gotten the credentials they need, and then, yeah, lots of bad things obviously happen from here. So how do we prevent this? So the first thing we could do